Hi, good evening, everyone. We are from Utthunga Technologies. Myself, Angadh Lambert, and behalf is Nirmal Tony Joseph. We are here to discuss about PROFINET Protocol. We will start with just briefing about the history of PROFINET. That would be better for the people who don't know about PROFINET Protocol and its organizations. We are expecting this section about 45 minutes, and remaining section like 15 minutes we have separated for interaction. That would be if you have any further queries, we can do an interaction sections. Please do use the chat section. That would be helpful for you, I think. If you can chat, I can see what's your query and I can reply to that. Profibus and Profinet International. Profibus and Profinet International is the largest field bus organization in the world with more than 1,400 members. Supports Profinet. They include leading providers of automation technology and users from the field of both production and process engineering. In Profinet, 5.1 million devices delivered in 2018. By the end of 2018, a total of 26 million Profinet devices were working to automate production facilities and all. Thus, Profinet is the world's leading industrial Ethernet standardized in IEC 61158. PNO is a umbrella group for PICC. It is founded in 1995. 35 working groups whose members come from the staff of 70 different companies develop the architecture of Profinet. More than 300 Profinet products from around 50 companies are already in the market. 11 authorized testing laboratories and 32 training centers have been set up for certifying these products. The global network of more than 63 Profinet competence centers can also provide answers to any of your questions regarding Profinet technology and how to design the architectures. You can see in the image, in India, Utthunga Technology is the first Profinet competence center. And we have been helping automation plans to develop the Profinet architecture and to design effectively. Profinet technology and certification. Appropriate quality assurance measures are required to ensure interoperability in automation system. For this reason, TI organization has established a certification process for Profinet devices, in which certificates are issued based on the test reports of authorized test labs. As I earlier said, test labs, some test labs are there all over the world that is authorized by PICC organizations. And any field device, any manufacturer, if I am releasing a Profinet device, it should be tested by the authorized test laboratory. That is a mandatory. These are the main topics for discussion. We discussed about this history right now. Now we will be going to the technology and how it works and complete advantages and all. And as I said, after in between there will be a section for interaction, and after 45 minutes there will be a section for interaction. You can chat in the below tab. You can chat. I think you can chat, and we can provide you answers. Profinet satisfies all requirement of automation technology, whether the application involves production automation, process automation. Profinet is the first choice across the board. As a technology that is standard in automotive industry, widely accepted in machine building, and as well as proven in food and packaging industries. Profinet has found its way all in these sections. New applications are radically developing nowadays, like marine and railway, and also day-to-day operations. For plant and machine manufacturers, the use of PROFINET minimizes the cost of installation and commissioning. For plant owners, PROFINET offers ease of plant expansion and high plant availability due to autonomously running plant units and low maintenance requirements. From this image itself, we can understand that earlier PROFINET was only dealing with the top level. Now, presently, it is coming to the lower level by adding up these links, proxy, couplers. The PROFINET is coming till the bottom floor. Benefits over other protocol. Ease of use. For plant and machine manufacturers, the use of PROFINET minimizes the cost for installation and commissioning. The plant owner profits from ease of plant expansion, high plant availability, and fast and efficient automation. Flexible network topology. Flexible network topology in the sense it can go up to line, ring, star, and redundant, different topology. It's really flexible for PROFINET. Integrated diagnostics. PROFINET include intelligent diagnostic concepts for field devices and networks. Cyclic diagnostics data transmission provide important information regarding the status of device and network, including a display of the network topology. Integrated safety. The plant owners and plant people know this. ProfiSafe is widely developing nowadays. ProfiSafe is the integrated safety device of PROFINET that reduces the wiring immensely in the network. High availability. PROFINET integrates automatically reacting redundancy solutions. The defined concept for media and system redundancy increases the plant availability significantly. Scalable real-time. Communication takes place over the same cable in all applications, ranging from simple control tasks to highly time demanding or motion control applications like synchronous, asynchronous, that we will be taking later. This type of communication can go through. Expanded system structure. Besides the conventional automation structure consisting of a controller and its field device, hierarchy structure with intelligent field devices and the shared use of field devices and input modules by multiple controllers can also be realized. Everything on one cable. With its integrated Ethernet-based communication, PROFINET satisfies a wide range of requirements, from data-intensive parameter assignment to extremely fast I/O data transmission. PROFINET thus enables automation in real time. In addition, PROFINET provides a direct interface to the IT level, like to the top level also. Support for energy optimization. With the Profi energy profile integrated in PROFINET devices, the energy used in automation system can be measured using a standardized method and controlled by selectively switching functions on and off without adding additional hardware. This is actually very useful in plants to conserve the energy, because plants can go for shutdown if it is not working in sometimes and go for some short pauses also. Global support. Specification and documentations are prepared within the global Profibus and PROFINET International Organization. A global network of competence center provide training and consulting. Establishment of the proven certification process ensures a high standard of quality for PROFINET products and their interoperability in plants. These are all some of the advantages of PROFINET technology if we are using in the plants and if we are using in the automation fields. PROFINET technology overview. PROFINET is process field network. when PROFINET it is expanded, we say it as process field network. It's a master to master communication, like provider consumer model. PROFINET we have four wires, that is send and receive at the same time. This communication technology is mainly TCP/IP transmission technology. That's why we can easily take it to the IT level. And what we call for this send and receive at the same time is full duplex. That's you can see in the image. Send and receive at same time. That's why we are attaining a 100 Mbps speed. If we are using a 8 wire, then it is a gigabit communication. For instance, I can say that two very useful technology is encrypted in PROFINET. Like if in a gigabit communication is running, if a cable is cut, it will automatically go to full duplex communication. Gigabit means 8-wire communication. Then some cable is having a damage, then it will go for a full duplex communication. Full duplex means 4-wire communication. This technique is known as auto negotiation. And also if PROFINET, if I change the send and receive wires, also it will work. This is known as auto crossing. These two techniques are really acceptable in the plants also. Moreover, in PROFINET, we can achieve star, tree, line, and ring topologies. That is the flexible topologies of PROFINET. PROFINET nodes depend on the update rate. And PROFINET is widely applicable in real-time data transmission. That's why data packet size is reduced and data transmission speed is increased. This update rate and nodes, we will come back later. We will be going through that slide after some time. Coding technology in PROFINET. Non-return zero inverse and multi-level transmit tree. In the image, we can see whenever it is 0, it is stable, and whenever it is 1, the state changes. Thus, we can acquire a high wavelength and low frequency. Thus, more information can be transmitted for a greater distance. Moreover, this will reduce interferences in the transmission. That's why PROFINET is in non-return zero inverse. Addressing in PROFINET is slotted into 3 topics: MAC address, IP address, and name. MAC address is the hardware address of PROFINET devices. MAC address has a fixed length of 6 bytes and is assigned by IEEE. The format is hexadecimal. The first 3 bytes indicate the manufacturer. The rest is freely assignable by any vendor or anything. In the example also you can see first three bytes is assigned by IEEE and other 3 is assigned by the Siemens or any vendor. IP address. IP address is assigned based on the device name using supervisor. Main purpose of IP is configuration, diagnostics, parameterization. And also it supports IPv4 and IPv6. Names. In PROFINET IO system, each field devices receives a symbolic name that uniquely identifies the field devices. That is, the name is used to relate IP and MAC address of the field devices. In PROFINET system, there are 3 components: controller, PROFINET device, and supervisor. In the PROFINET controller is PLC. The device is PROFINET device. You can see the white color device, and the supervisor is optional. In a plant, unit always contain at least one controller, should always contain at least one controller and one or more devices. Supervisors are usually integrated only temporarily for commissioning or troubleshooting purposes, like for some diagnostics or any plant checkup purposes, we will be using supervisors. From the image, it's very clear who is the supervisor, who is the controller, and the device. And controller and device will be exchanging configuration data, process data, and alarms data, while supervisor and field device, PROFINET device, will be exchanging diagnostics data, status or control data, and parameterization data only during troubleshooting or commissioning. Supervisor, since it's a optional. The device model describes all field devices in terms of their possible technical and functional features. A data access point is the access point for communication with Ethernet interface and the processing program. A variety of I/O modules can be assigned to it in order to manage the actual process data traffic. The slot designates the place where an I/O module is inserted in a modular I/O field device. Inside the slot comes the subslot, where the actual process data is exchanged. The data contents of subslot is always accompanied by status information, from which validity of data can be derived. That we can understand from this image itself. It's very clear. Communication services. In PROFINET, communication services contain UDP/IP, RT, and IRT. UDP/IP is user datagram protocol. It's an open communication via Ethernet. It is transmitted in 100 millisecond, mostly a cyclic, non-time critical transmission of data like parameterization, configuration, and diagnostics comes under UDP/IP. While real-time RT, in our real-time, cycle times can be realized in the range of 5 to 10 milliseconds. PROFINET real-time is fully compatible to TCP/IP standards without any restrictions. All PROFINET devices must support RT, which usually means around 250 microseconds to 10 milliseconds. And then comes the asynchronous real-time. Some applications like closed loop motion control require not just low cycle times, they also require specific behavior from the network. The data should be strictly sequenced and should never be vulnerable to collision or jitter. Jitter is nothing like, it's a delay in the packet from the devices to controller. Asynchronous real-time networks can operate with cycle times as low as 31.25 microseconds. That is 32,000 samples per second. It's, as we say, it is below 1 millisecond. Standard cables are AWG-22 and it is in Cat5 standard, and maximum length that can be assured is 100 meter. Connectors, usually we use our RJ45 connectors and M12 connectors. And as I said, PROFINET is a 4-wire transmission. There is a color code for each wire. Like yellow and orange is used for transmission, while blue and white is used for receiving. PROFINET architecture and line depth. This is a very specific topic for plant owners or whoever dealing with the real-time plants and facing some downtime in the architecture and the PROFINET architecture and all. Maximum devices or nodes that can be connected depends on the update cycle time of controller. From the table right side, we can understand that for 1 millisecond update cycle time, we can have only 7 hops and maximum of 70 devices. Then what will be a hop? you'll be having a question, right? Hope in the sense you can see in the left side image, we have connected 5 devices and one switch in between. Thus, data will be having a 6 hop to reach the controller. For an example, I will just say a case. If I am having a PLC with cycle time of 1 millisecond, as per PA standard, I will go up to maximum of 7 hops. So after the 6th hop, I will connect a switch. But for 1 millisecond cycle time, maximum devices that can be connected is 70. Even if I'm stretching with the switches, I should look how many devices that can be connected to the overall network. That depends upon the update time of the controller, update time set in the controller. This is actually very important to design the PROFINET architecture, and also we can understand how to reduce the downtime, what is happening in the network or architecture. Now we will be going to a little bit communication related section. If you are having any doubts for this much section, we can interact now. Complete technology we have spoken right now. Now we will be going to in depth of how this communication is happening and how communication relations and somewhat in depth and insight of PROFINET. This is actually basic PROFINET technology what we heard right now.
So is this built on top of TCP/IP?
Yeah, TCP/IP itself.
Okay.
Then if you don't have any doubts, I have framed one question. Like I will be we can compare Profibus and PROFINET. Profibus you will be familiar because in Indian market Profibus is really familiar with a lot of plants and a lot of manufacturers know about Profibus. What is actually the difference between Profibus and PROFINET? Profibus is process field bit unit system, while PROFINET is process field network. Difference is mainly the cable is different. Profibus communication is RS485 technology, while PROFINET is TCP/IP technology. In Profibus, we can go up to maximum of 12 Mbps speed, while in PROFINET, we can go maximum of 100 Mbps. And the coding technology of Profibus is non-return 0, while in PROFINET, as we studied right now, it is non-return 0 inverse. And Profibus is, as we say, it is half duplex since two-wire communication. It's a differential voltage communication happening in Profibus, while in PROFINET, right now we studied, PROFINET is full duplex with four-wire communication. That's actually a glimpse of what we studied right now. It's a difference between Profibus and PROFINET. Now we'll be moving to a little bit in depth to PROFINET. If you have further doubts, we will discuss after later. We'll be having a 15 minutes time for interaction. Communication relations. To establish communication between the higher level controller and an IO device, communication paths must be established. Every data exchanged will be embedded into application relations. Within the application relations is the communication relations which specify the data explicitly. As a result, all data for the device modeling, including the general communication parameters, are downloaded to the IO device. An IO device can have multiple application relations that you can see in the right side image. And in the image left, you can see the controller talking to a device. In acyclic mode, record data communication relation. In cyclic mode, IO data communication relation. And alarms are alarm data communication relation. These are all embedded in communication relation within a application relation. Cyclic data exchange. Cyclic data are transmitted via the IO data communication relation. Last topic was that communication relation, IO data communication relations. The cyclic data exchange is nothing PROFINET real-time communication within the range of 250 microsecond to 512 millisecond. Cyclic data exchange can be realized with standard Ethernet controllers and takes place without any TCP/IP information, that is directly to the layer 2. That's why we are getting 100 Mbps speed and a real-time communication. We are skipping directly to the layer 2. In the image, you can see the controller and 3 devices. In the first device, it is update time is 1 millisecond, and for the second device, it is 2 millisecond, and for the third device, it is 4 millisecond. Thus, the first device will update every second. Thus, you can see the green color data is updating every 1 millisecond, while the second device will update every 2 milliseconds. That's the black color data you can see every 2 milliseconds is updating, while the third device having 4 millisecond update time is updating only once in the 4 millisecond. Thus, it runs in cyclically. A cyclic data exchange using the record data communication relation can be used for parameter assignment or configuration of IO devices or reading out status information. This is accomplished with the read or write frames using standard IT services via TCP/IP. The image shows acyclic and cyclic communication, how it's happening. Cyclic communication, using cyclic communication, we are talking to the devices, sensors, while acyclic communication is used for configuration, parameterization, and I can read or write, or I can, using a supervisor, I can configure whichever devices I want to talk, or the controller need to talk in cyclic manner. A status-based maintenance approach is currently gaining relevance for operation and maintenance. A system for reliable signaling of alarms and status messages by the IO device to the controller was defined for PROFINET IO for this purpose. This alarm concept covers both system-defined events, such as removal and insertion of modules, as well as signaling of faults due to wire break or voltage issues. This is based on a state model that defines good and defective status, as well as maintenance required and maintenance demanded pre-warning levels. In the image, we can see IO controller is talking to the IO device, while IO device will be sending some information like alarms. In the alarm itself, it is classified into 3: maintenance required alarm, maintenance demanded alarm, and diagnostics alarms. Network diagnostic and management. SNMP is nothing but Simple Network Management Protocol, and LLDP is Link Layer Discovery Protocol. SNMP is for collecting and organizing information about managed devices on IP networks and for modifying that information to change device behavior. LLDP is used by network devices for advertising their identity, capabilities, and neighbors on a local area network that is based on IEEE 802.1. In existing networks, SNMP has established itself as a standard for maintenance and monitoring of network components and their functions. PROFINET field devices use the LLDP to exchange the available addressing information via each port. This allows the respective port neighbor to be specifically identified. Also, physical structure of the network to be determined. In the image, it is clear what is SNMP and LLDP is doing. SNMP is collecting details from the neighborhood, while LLDP will be mapping the path. We can take an example. Here's one example for LLDP. In this image, you can see the PROFINET device 2 is connected to port 003 of switch 1, and it is talking via port 001 to the controller. With this neighborhood detection, the LLDP will detect this neighborhood detection, and a preset or actual comparison of the topology is possible, and changes of the topology during operation can be recognized immediately. As I said, LLDP is path mapping, while SNMP is detailing of neighborhood. Device replacement. If a device fails in a non-topology, it is possible to check whether the replacement device has been reconnected in the proper position. It is even possible to replace device without the use of an engineering tool. In the picture itself, it's clear while first the device was working fine, in the second the device was not working fine, then we will change with the new device with same spec. Then the controller will automatically detect the device and provides name also, and moreover it will start the communication immediately. Synchronous real-time. Cycle data packets are transferred as synchronized packets on a reserved bandwidth. All other packets, such as packets for diagnostics or TCP/IP, share the rest of Ethernet bandwidth. By default, the minimum update rate is defined at 250 microseconds. For maximum control performance, this can be reduced to as low as 31.25 microseconds. In this image, we can see controller can set a clock master, and devices will be accurately setting for that particular time and giving a response synchronously. Coming to a device integration, general station description. In PROFINET, this is GSD-ML. It's called GSD-ML since file is described in XML format. The content of GSD file contains configuration information, parameters, modules, diagnostics, alarms, and device identification. The XML-based GSD-ML describes the properties and function of the PROFINET IO field devices. The field manufacturers has to provide this GSD-ML. Thus, in the image, we can see if the field manufacturer provides us GSD-ML using an engineering tool, I can download and upload the device and start communication with the IO devices. In the below the PROFINET line, you can see the IO devices. Thus, I can start communication. Electronic device description language. The configuration, parameterization, commissioning, maintenance, and diagnosis of the device from the engineering system requires a more efficient language. Thus, EDDL came into picture. The EDDL technology enables a host system manufacturer to create a single engineering environment that can support any device from any supplier using any communication protocol. EDDs are structured text files that contain configuration information written in electronic device description language. These are also provided by the manufacturers. And FDT and DTM. FDT is field device technology, while DTM is device type manager. In contrast to the GSD, ML, and EDD, FDT and DTM technology is a software-based device integration method. DTM is a software component and communicates with the engineering system via the FDT interface. You can see that image. In the image, DTM is used to communicate with the FDM interface and connecting. We are getting the data from the devices. FDT technology provides a standardized communication interface between field devices and monitoring systems, used for configuration, maintenance, and diagnostics. The key feature of FDT are its independence from any communication protocol and the software environment of the host system. FDT technology allows any FDT-enabled device to be accessed from any host using any communication protocol. These are some advantages. In the right side image, you can see what is the advantage of GSD, FDT, and EDD lined up. This is actually a huge topic: GSD, EDDL, FDT, DTM. We have briefed out in a short manner right now. Then PROFINET optional functions. Fast startup. Fast startup defines an optimized system power-up in which data exchange begins much faster, starting with the second power-up, since many parameters are already stored in the field devices. This optional path can be used in parallel with standard power-up. Configuration in run. Configuration in run are carried out in PROFINET without any interruption and without adversely affecting network communication. This ensures that planned repairs, modifications, or expansions can be performed without a planned shutdown. Like for a continuous running process automation or production plants, we can use these techniques to without any shutdown in the plants. High availability. High availability is nothing if I am connecting in a line structure, if one of the device fails, the entire device will go into a failure mode. So redundant technology, ring redundant technology can help in this maintaining without any shutdown. Multiple access to the field devices. In the case of shared input, there is parallel access to the same input by two different controllers. Thus, an input signal that must be processed in two different controllers of a system does not have to be wired twice or transferred via CPU to CPU communication. Application profiles. Application profiles are joint specifications concerning certain properties, performance characteristics, and behavior of the device and systems that are developed by manufacturers and users. Main application profiles are PROFISAFE, PROFIDIVE, and PROFIEnergy. PROFISAFE and PROFIEnergy we have discussed earlier in the first section. What is the advantages of PROFISAFE and PROFIEnergy? Anyway, I will go through it. What is the technology? The use of PROFISAFE enables elements of a fail-safe controller to be transferred directly to the process control on the same network. The need for additional wiring is eliminated. PROFISAFE can be used with Profibus and PROFINET. Like PROFIDRIVE. It refers to the specification of standardized drive interface for Profibus and PROFINET. This application-oriented profile, which is standardized in IEC 61800-7, contains standard definitions for communication between drives and automation systems. Thus, it will be assuring vendor neutrality, interoperability, and investment protection. In the right side image, you can see it will be protecting the drives, what motors or VFDs. While in the PROFISAFE, you can see the left side image, the wiring is entirely reduced. You can see the red color circle, that's a PROFISAFE. mounted near the controller. It's used mostly in the hazardous area. Profi Energy. Profi Energy enables an active and effective energy management by purposefully switching off unneeded customers. As I said, Profi Energy can be used in the complete plant also. If a complete plant can go in a pause or shutdown mode, if it is not working or if some device is not working, they can conserve energy. Now everyone is going behind this conservation and energy management, so this would be a great technology in Profinet. Integration of field devices. Profinet specifies a model for integrating existing Profibus systems and other fieldbus systems such as Interbus and DeviceNet. This means that any combination of fieldbus and Profinet-based subsystems can be configured. Thus, a smooth technology transition is possible from fieldbus-based systems to Profinet. In the image, we can see a proxy is connected to talk to the Profibus DP. And for example, for instance, in Siemens FDC 157, we can communicate to Profibus PA. It's actually a coupler for Profibus DP. In some cases, like plant owner would like to be able to integrate existing installation into a newly installed Profinet system easily. And plant and machine manufacturers would like the ability to use their proven and familiar devices without any modification for Profinet automation projects itself. And also device manufacturers would like the ability to integrate their existing field devices into Profinet system with reducing the cost. This will be very easy in Profinet system. Using proxy, device couplers, gateways, we can integrate to any other field buses. Continuation of integration itself. Compared with production automation, process automation has a few special characteristics that contribute to defining the use of automation to large extent. For one, plant can have a service life of many decades. This gives rise to a requirement on the part of plant owners for older and newer technologies to coexist in such a way that they are functionally compatible. Further, the requirements for reliability of process system, particularly in continuous process, are often considerably greater. The requirements mainly include the acyclic data exchange and integration of field buses like PA, HART, FF, DP, and also configuration in run, diagnostics, maintenance, redundancy. All these features should be added. You can see in the image itself, every other protocol is linked to a single Profinet architecture itself, like PA, HART, FFH1, and DP is talking in a Profinet architecture itself. So this is a brief webinar about Profinet technology. And if you are having any further doubts, we can discuss now. We have 10 to 15 minutes. Curious. Hello.
Hello. Yeah, I have one posted on the chat. So how is that time sync? Is it initiated from the controller, or the controller need to connect to any external system to do time sync across all the devices?
It is from the controller itself.
Okay, so the controller initiates the time sync.
The controller initiates the time sync. The master clock is in the controller itself.
Okay.
So how this actually happens is all the Profinet devices will get their time from the controller. And if you need to have, say you want to sync with an external source, clock source, then you actually sync your controller to that clock source.
Okay, fine.
Jubin Abraham.
Hello.
Yeah.
Okay, I've just put a question regarding this proxy.
Yeah, proxy, right?
So can I just introduce proxies to existing control system
Okay.
and get acyclic data for further use? So
Okay.
just want to know whether this proxy is for migrating from existing Profibus or Profibus to Profinet control network, or
Okay.
can I use proxies for other uses?
Proxy specifically, if I am using Profinet to DP proxy, that is specifically for Profinet to DP. That is specified, right?
No, my question is, I have a DP network which is
Okay.
used for control. So I introduce one DP to Profinet proxy. So that is now on the Profibus DP line. So
Okay.
the master remains the old Profibus master, and I
Okay.
have a proxy in between. Now, other side of the proxy, I have the TCP line. So can I just pull data, use just Profinet for just data pulling, but not for control?
Okay. Okay, that you can do, right? From the TCP IP itself, since this Profinet is in TCP IP technology, we can pull it out. You have tried that?
No, I'm not. We are not. I'm not tried.
Okay, you can try that, and if you have any queries, you can contact us in that mail ID. We have given the mail ID. We can assist you in that. No issues.
No, I'm not from a
Hello.
old EGD reach the downstream devices which are using Profinet, which is obviously faster and
Okay.
have the TCP connection. So in terms of connection to an existing DP line, if you just see Profibus DP, it does not work well in multi-master connection. So other than engineering system, any interference I guess will not be tolerated. But if I have a Profinet proxy in between, I just want to know whether the existing DP control will be affected so this seems to, I'm saying if this is possible, there is no need to, the engineering station needn't be on DP. It can be always on the TCP.
Okay, engineering station is in TCP, yeah.
Yes, so
Right.
no, is it possible?
Yeah, it's actually possible. We also have this network here.
Yes.
We also have this DP to TCP IP.
Okay.
Actually, what is your requirement? Actually, you can pull it out. We can get back to you. No issues with that.
Yes, I will use
It's
the
a
mail ID.
little bit complicated requirement, I think. You can get back to us in this thing. We will get
Yes,
surely.
sure,
This
sure.
in the mail ID, you can mail the requirement. What is your query completely, or
Yes.
with the architecture? What
Yes,
architecture you have?
yes. Yes. Now another question would be, in one of the slide you told it is Profinet master to master. So publisher subscriber is known, but once in publisher subscriber model, do you call something as master? Because there is no master concept there.
No, there is no master concept. Just I'm
Yes,
saying like it is a broadcast, right? There
I
is
understand.
no master and slave. Master and slave is Profibus communication.
Yes, so in the slide it is written master to
Yeah,
master.
master to master communication. That is not that evident. It is like
Okay.
broadcast.
Yes, so yes. Okay, fine.
Thank you.
So, okay, fine.
If anyone have further queries, please contact at utthunga.com and give us the feedback. How was our first webinar? It was our first webinar, and we are helping automation sectors and plants in Profinet technology.
I have one question. So how do you compare this with OPC UA protocols? Is it complementing each other, or is it OPC UA can be on top of Profinet?
OPC UA, I have to check that. I have to check that. I will get back to you then.
Okay.
Any suggestions also you can give us for this webinar also. If you found any more add up we needed, also you can give us comments. And please get us at contact@utthunga.com. This is the main portfolio of Utthunga. We are actually into IT/OT convergence and OPC solutions, but I'm not into OPC departments. That's why I couldn't get back to you there. And engineering services, and also network diagnostics. These are all main portfolio of Utthunga Technologies. So I think thank you for your time.
Yep.
It was a nice interaction. I hope it was a nice interaction.
Yeah, it was good. Thank you, guys.
We will be hopefully catching up for a webinar 2.0. Thank you.
Thank you.
Thank you very much, Angadh. Thank you.
Thank you.